Good morning, guys. We're going to try to give you an update on soil fertility, our recommendations for 2023. And this is some collaborative work. I'm going to show you some work also from Dr. Brenda Tubana from LSU. First picture here is we're cutting a nitrogen test right on the river in Vacherie with, a good test over there. Well, as he said, if we didn't have to worry about money, this would be a lot easier, a whole lot easier. But obviously we do. So let's start out where we are right now. These are numbers that right here we have the numbers from last year. And then right next to it we have the 2023 numbers from January 24. So let's look at anhydrous. So why do we look at anhydrous? All right, we don't really use much anhydrous anymore. So what the heck do I have it up there for? Anhydrous is the building block for almost all the other nitrogen products that we do use. So you got to start with anhydrous to make 32%, to make your urea. So, and anhydrous production is tied to the price of natural gas. So that's the thing that's driving that price up. Now it has come down a little bit, about 15%, but we're still above $1,200 a ton. Urea has also dropped about 13%, but we're still looking at $800. Not a whole lot of folks are using urea. Is there anyone here that does use urea? I know a few folks out in the Vermilion Parish area that have used urea, that have a total dry program. But most of us are looking at 32% as the main nitrogen source. And that really hasn't moved a whole lot. We're still above $600 a ton. And of course, potash has moved the least. Still looking at $750 a ton. There's a little bit of hope that that might move. Canada is starting to increase their production. Canada is actually the #1 producer of potash in the world. And they're starting to actually move a little more potash, so maybe that price will start to come down. All right, that being said then, so your priorities, if you've got to make the decisions about where to cut and what to include and what to not include, this is kind of our suggestions. I mean, obviously soil pH is going to be super critical when you have high fertilizer prices. You want to make sure that is correct. You want to make sure that you're not having situations like where you have a pH 5 or below, because if you do put out that expensive fertilizer, you're going to tie it right up and you won't have the benefit. So make sure your pH is corrected. And then of course next will be nitrogen. You can't grow a crop without nitrogen. That's going to be your second priority. Our recommendations that we have online are very good, and I think they're certainly, we have well over 100 trials that support that work, so I think you can go by those. Traditionally we had potassium, but last year we did this, and I'm going to stick with it this year. All right. Third priority should be sulfur. And I'm saying that because when all the research that we've done, our most consistent results in terms of yield response has been with sulfur. We still see it with potassium, but we see it more consistently with sulfur. If you're missing sulfur, you're going to notice it. So fourth would be potassium. So I'm certainly not saying don't put it. I know it's a hard decision with the price where it is. So concentrate on where you're testing low or very low. If you've got to make the decisions, if you got those areas where you're really testing low, that's where you want to hit first. And then finally, micronutrients. We're looking at zinc and boron are the main ones that we have studied and worked with. I'm going to share a little bit with boron data today. And finally, phosphorus. All the work we've done haven't shown a benefit of putting it in the spring. We have seen some benefit to putting it at planting, particularly if you've got areas testing low where you're planting. That's the time when you want to consider a phosphorus application. We've shown this frequently. I'm just going to go through pretty quick. Obviously, I already said we add the line to adjust soil pH to maximize nutrient availability. Key when you're looking at high prices. 5.8 and 5.2 are the two pHs that you're going to be looking at. 5.8 on sandy loam soils and 5.2 on your heavier clay soils. We're broadcasting to fallow fields. We're coming up with a rate based on a soil test. Okay, and that soil test hopefully is going to adjust that pH to about 6.5. And finally, remember, not all limes are created equal. You may get a great deal from some guy, some company that sells you this material. But even if you get that great deal, you want to look at the lime analysis. Okay, what you're really looking for is the CCE, calcium carbonate equivalent. What's the ability, the neutralizing ability of that material? Your lime rate that you get from your soil analysis is going to be based on a CCE of 100%. So if you get a material that's 50% CCE, you'll have to apply twice as much. Pretty simple. And you obviously want a good particle size distribution. If the material you got is big chunks like this, it's going to take an awful long time for that to react. And obviously, if it's all really fine, it'll react really quick, but you won't have a buffering of your pH. That pH will start to go down pretty quickly. So it's good to have a combination. All right, well, as far as we mentioned nitrogen, we'd just like to update some of the newer varieties that we've begun working with. 615 plantain. This is with Ben Rodrake. That first slide I showed on the river and Vacherie, this is that test. Just to set it up here, starting on the left, the orange or yellow slide is no nitrogen. Then we have 40, 80, 120, and 160 units. In this case, the 120 pound rate gave us the best cane yield. But as we typically see when we looked at the TRS with the higher nitrogen rates, the TRS drops. In this case, dropped quite a bit, almost 20 pounds per ton. So you put that together and you can see the kind of sugar per acre levels off, and the little letters tell us that 80 pounds would have been our economic rate because there was no statistical difference between those top three. And this is some 804 second stubble. 804 in some of our work may need a little more nitrogen. We're trying to see, or we're seeing a little bit more of a suggestion that it might use a little bit more nitrogen, but in this case, 120 units was our optimum for the second stubble here, and TRS, not a big difference, but sugar per acre, again, the little letters say 120 units, all of which falls in with our current recommendations. Brenda Tubana, as I said, my colleague from LSU, she's been looking at some alternative nitrogen sources other than just straight 32%. She looked at this Anhydrous material, which is kind of a controlled release material. And then we had the UAN plus calcium nitrate, urea, and urea plus ammonium sulfate. And what we have on the left, we have a silt loam soil at St. Gabriel, and then we had the Sharkey clay at St. Gabriel. On the clay, she saw no difference between anything, okay? So either sugar yields or cane yields. On the silt loam soil, she actually saw a little bit of an advantage to using urea, okay? But there wasn't a big difference. Well, if you put all that together, our current recommendations are going to stay where they're at last year. Plantain light soils 60 to 80 pounds. Plantain heavy soils 80 to 100. Stubble cane light soils 80 to 100, and stubble cane heavy soils 100 to 120. As I told you guys, we got well over 100 trials now that support this information, support these recommendations. We've done it all over, all different areas, all different varieties, all different soil types. So we're pretty comfortable with these current rates and recommendations. We do assume you fix the pH, okay? And we're targeting that application date somewhere in April. You fertilize by the crop, obviously not the calendar. We'll see what the season holds. If things warm up and start taking off, we'll be towards the earlier part of that. Conversely, if we get, things turn cold, we might be pushing towards the other end. All right, last year I showed you some information about nitrogen stabilizers. Okay, this is something relatively new we started to work with. And what they're doing is nitrogen stabilizers are controlling the transformations between your different nitrogen compounds. If you're using 32% nitrogen, okay, that particular mixture has nitrogen in 3 different formats. You have it in urea, then you see this NH4+, that's ammonium, that's about 25% of your 32%, and the other 25% is nitrate. So you see nitrate has a negative charge on it. Your soil is negative. So what's that mean? They're going to repel each other. So nitrates can leach very easily and can be lost and leach out of the profile. Ammonium has that positive charge. Soil's going to hold on to the ammonium, so that won't leach anywhere near as readily. So these 2 inhibitors that we're looking at, the first one is going to slow down the reaction of urea to ammonium, because the other thing about ammonium, even though it doesn't leach, it can volatilize, which means it can be lost as a gas if you don't get it incorporated well in the soil. If the soil stays real dry, you can lose it to volatilization. The second reaction, there's some microbes in the soil that convert ammonium to nitrate. So this second inhibitor slows that down. So if you put both of these out, what's it going to mean? You're going to have more of your nitrogen as urea and more as ammonium. So you'll have less leaching, you'll be keeping more of your nitrogen in the soil profile. So we put out some tests. This is at Rebecca Plantation with Drake Gravois on Plancane 615. Looking at these slides, again, the orange yellow one is a control. The control has nitrogen, it has sulfur, it has potassium. It just doesn't have an N stabilizer. Then the pink one is a urease inhibitor. The green and the purple are 2 different rates of a nitrification inhibitor, and the white one is material that has both urease and nitrification. So you look at this, and when that material that had both, we increased cane yields by 6 tons, and it was a significant increase. Not much with TRS, but look at the sugar increase. You know, so both the high rated N nitrification inhibitor and the rate, when we had both of the materials, we had a nice increase. Here's some more Plancane 615 with Brian Ellender, south of Houma. In this case, every inhibitor that we put out increased cane yield. All right? Again, not much with TRS. Significant increase in sugar yields across the board, some pretty big increases. What are we doing? We're keeping more of the nitrogen where we want it, where the cane can use it. This is some first stubble 299. This is the first trial we did last year. It was plant cane data we showed you. It's a little bit different in that these are both the pink one, or the purple one and the white one. Both have both inhibitors in it. This is a little bit lower rate. That was the best treatment for cane yield. Not much for TRS. And again, not as dramatic as plant cane, but still showing you an advantage. So bottom line about inhibitors, you're looking at the material that we use in this particular project, $8 to $10 an acre. All right, that's what you're looking at. So it seems to me like it's something worth considering, particularly NRCS often will cost share for this. Talk to your NRCS person, you can get on a program and they might be able to cost share with this. It's good insurance. Okay, definitely something to consider. Okay, number 3rd priority, we talked about sulfur. We've been doing sulfur work for quite some time. You know, most of our common varieties, 299, 540, 615. The rates went from 0 to 75 pounds. We've looked at both the liquid source, the ammonium thiosulfate, and also ammonium sulfate. And we're doing this because our current recommendation is 24 pounds, all right? We think that's an outdated recommendation that needs to be brought into current times. that 24-pound recommendation was created when we were getting all our free sulfur from acid rain. Okay, since EPA came on board and stopped that, we lost our free sulfur, and now we're really seeing the need to put additional sulfur. Okay, so this is set this slide up again. Orange, yellow, all the way to the left is a control. No sulfur, but it has nitrogen, it has potassium and everything else. And then we have 25, 50, and 75 pounds of the liquid ATS, 25, 50, and 75 pounds of ammonium sulfate. The thing that jumps out here, our 50-pound and even the 75-pound rate are giving us the best yield response. Remember, our recommended rate is 25 or 24. In terms of sugar yield, same thing. That 50-pound rate and even the 75-pound rate are giving us the best response. That's second stubble 540, so first stubble 615. Same trend. Here's the 50-pound rate of ammonium sulfate and then 50 pounds of ATS. And then look at some first stubble 615 from Laurel Valley and Thibodeau. In this case, every single sulfur application increased yield over the control. And here's sugar yields, again, nice increases, very impressive in some cases. And remember, this is a 75-pound rate, 3 times higher than our current recommendation. Okay, so that, one of the other things we noticed about sulfur is we have guys that have been putting it consistently. Every year, they're putting that 24-pound rate out. And you know what, and they take soil samples and they're noticing their soil test still is going down. What the heck's going on? We're putting it and we're still seeing a decrease over time. It means that your cane is using every bit that you're putting out and still looking for more in the soil, so it's mining the soil, so you're seeing a decrease. So one of the things we decided to do is look at, to see if we could come up with a way to increase the soil levels over time. So what we're doing is we're combining elemental sulfur with gypsum. Elemental sulfur in the sulfur form, sugarcane can't use it, all right? It's not a plant available form. It has to be broken down in the soil, okay, to sulfate. That takes 2 to 3 months sometimes. So basically what you have is a slow release sulfur source, right? Gypsum, on the other hand, is a sulfate source. So that's something your cane can use right away. So by combining these two materials, we're hoping that over time, we're going to be able to bring those sulfur levels in the soil up, so we'll be able to be in a much more favorable position where we won't have to put these high rates. So in this particular study, this is some plant cane 299 in Morganza with Dallas Ardoin. And in this case, we had the control, then we had 25 and 50 pounds of elemental sulfur, 25 and 50 pounds of gypsum. And then we had this combined 12.5 pounds of sulfur and gypsum, and then 25 and 25 sulfur gypsum. Plant cane data, the 50-pound rate of gypsum seemed the best for this study, and then the split rate at 12.5 pounds. Sugar yield, the split rate was a little bit better. In 615 plant cane, a little bit different, where we had the 50-pound rate of sulfur was good, and so was 25 pounds of gypsum. 25 pounds of gypsum was the best here in terms of sugar yield. The key thing to take about this one here is we're looking at the long-term effects, so it's more important to see what we're doing. The soil test levels, but just wanted to give you an idea of what we were working on. Some more data for Brenda. Again, she's looking at some alternative sulfur sources. In this case, all the way on the left is her check, no sulfur. She looked at potassium thiosulfate, ammonium thiosulfate, and elemental. Key thing here, she's also seen potassium thiosulfate more than that 20-pound rate. The 40-pound rate was the best. And in the ammonium thiosulfate, her 60-pound rate was the best. Elemental sulfur, she saw something a little bit different. The 20-pound rate was okay. Same thing with cane yield on the bottom. So the bottom line here, you need sulfur and probably need more than 20 pounds. Last sulfur slide. It's kind of hard, maybe hard to see in here, but This is a test that I didn't put out at all. This was put out by two farmers, Lance Gaudet and Keith Dugas. And I think they were trying to figure out if I knew what I was talking about, and they might not have believed me about sulfur completely. So they did their own trial. And what we have here, this is some strips with sulfur, and this is some strips without sulfur. Okay, and it's a 24-pound rate. That's just the 24-pound rate. So they put it out, and they found out pretty quick there's a huge difference in color. Very obvious, you know. And they actually used our yield monitor. And where we had sulfur, we had 47 tons per acre. Where we didn't have sulfur, we had 42 tons. We lost 7 tons, or 5 tons, excuse me. Where we had it, 13,500. Where we didn't, 11,004. 2,000 pounds. They did a plant tissue analysis that Brenda analyzed. Where we had it, we were at 0.26%. Where we didn't, 0.18. So big difference. You can tell the plant didn't have as much. The critical level for sulfur, okay, that's the level that we use to say we know for sure the plant's deficient, is 0.13. So we're way above that critical level, and we're still seeing this type of a difference. So that should let you know, and just to make sure that you understand that this is sulfur and not nitrogen. She did a nitrogen analysis. Where we had sulfur, it was 1.5%. Where we didn't, it was 1.9. So we had more nitrogen in the no sulfur plots, actually, and you still had those differences in yields. Hopefully that will further convince you on the importance of sulfur. So just wrapping up here, we've demonstrated consistent benefits to sulfur. Current recommendations probably too low. Soil test levels for many locations continue to decrease, even though we're putting that sulfur. And we've seen positive yield increases up to 75 units. And we'll keep you up to date on our gypsum and elemental sulfur work. All right, last couple slides here. Talking about boron. We've been doing boron work for a number of years. 299, 804, 615. The rates went from 0 to 2 pounds. We're looking at a liquid source. We're either doing foliar or we're doing soil applied. Okay, those are our two options. And we started to do this work because I do over 1,000 soil samples a year for the research, and more of those are coming back low in boron. Does that matter? That was why we did this research. Should we be concerned about that boron, low levels of boron? So here's a trial. This is with Dickie Ellender, some 615 plant cane. What we have here is the control with no boron. Again, no boron, but it's got nitrogen, it's potash and sulfur. It's got all those other things. Then we have foliar boron at 0.5, 1, and 2 pounds. And then we have soil applied boron at 0.5, 1, and 2. And you can see a half a pound of foliar boron picked up 5 tons, just like that. And then the 1 pound soil rate, we even had a better increase, about 7 tons. So pretty remarkable for just that little bit of boron. TRS, not too much of a difference, but when you look at the sugar yields, again, those two treatments really stick out. So all in all, the majority of our treatments with boron showed us an increase in sugar yields. Okay, the one thing to add about boron, pay attention to your soil test. It's not something, if your soil test comes back that you don't need it, you don't need it, right? If it comes back that you do need it, that's when you consider. We've actually, at our research farm, when we first started looking at boron, we were deficient. We started to put it. We brought the levels up, so now we're more at a maintenance level, okay? So pay attention to your soil test for boron.
Let me ask you your last slide, your third column over, where you see a decrease in your sugar per acre. Is there anything, I'm trying to grasp this and see what I'm missing, trying to read the legend here, but what may have happened to have it to go?
There could be a lot of different situations, a lot of different, when you're doing the field research. I mean, these are small plot research, this is a small plot. I mean, I don't have a good explanation why that was, why
I
that
just
was
didn't
low.
know,
No.
why that threshold was from half a
Yeah.
pound to a pound.
Sucrose is a very repeatable trait, biomass is a highly variable trait, you have just a lot of noise naturally in it.
Okay.
When you say applying fully, when are you applying it, what time of year?
In the spring, fertilizer
After
time,
fertilizer?
yeah,
You spraying it over the top?
yep.
Like
Yeah,
if you had a year of rust and you put in, something for rust,
you could do it then, you could put it at lay-by. I mean, if you could rig up to do that, you can do that, yeah. Most of these materials are all, you can, mix them, no problem, tank mix them. Most of our guys though, that we worked with weren't too interested in foliar, they were more interested in soil applied, so that's one of the main drivers for this work, to see if we saw a big difference between the two application methods. And taking all the experiments that we've done, no, there's not, so
You
it's,
have any,
it's,
cost analysis or what it cost? Like, just to put like the half, since the half pound looks like foliar is doing pretty good.
foliar did pretty good. We're looking mostly at that pound rate seems to be, and the last numbers I had was again around that $10–12 an acre number is what I've been seeing per pound. So that's the last number that I had for that.
Yeah, and that's why it was weird to me, because when you look at a pound from a foliar application versus a pound soil application, they seem to be,
Right,
the opposite. One is the lowest and one is the highest relative to,
right. And that's just, this is more or less a fluke here, to be honest.
okay.
Okay. But it is clear that I do want to make the point though, that pay attention to your soil tests, because boron definitely appears to be one that if your levels are good and your soil test isn't calling for boron, you probably don't need to worry about it. But if it is calling for boron and you're deficient, okay, then it can pay off. Okay, that's the reminder, that's the recommendations, pH, nitrogen, sulfur, potassium, micronutrients. And just want to acknowledge the American Sugarcane League. They supported all this work to make it possible. My crew, my all-girl band that I work with, and then all this work was done on farm, okay? Not on the research farm, it's done with y'all. So I appreciate all the help for the cooperating growers. There's my contact information if you need to get a hold of me. Any other questions?